Hi everybody, thanks for watching. In this video, we're going to take a look at how to calculate something called average atomic mass of an element, giving its common isotope and percent abundance data. Let's review some important things first, starting with the idea that not all atoms of an element have the same mass. We've looked at carbon many times. Some carbon atoms have a mass of 12, others 13, others 14. The real differences between these is all about those protons and neutrons. Since they're all carbon, they're all going to have 6 protons. They're the same element, so they have to be the same. So the real difference in mass is caused by the neutrons. 6 for the carbon 12, 7 here, and 8 for the carbon 14. We even have a name for these called isotopes, which is fully covered in a previous video. This video is really about when you put these symbols on a periodic table, like for carbon, what number should you use? The protons are easy. The atomic number is always 6 for carbon. But the mass can change. Do you put 12, 13, or 14? And what the periodic table decided to do was to average those masses. And that's why you'll often see decimals, because averaging numbers like 12, 13, and 14, obviously, you can get a decimal answer. So that's what we're going to take a look at how to do coming up now. Before we do that, there is one other idea you have to understand, and that is percent abundances. Sounds scary, but it's a pretty simple idea. It simply shows for each isotope how common or abundant it is. So for carbon 12, it has a percent abundance of 98.9%. That means of all the carbon atoms in the whole universe, almost 99% of them have a mass of carbon 12, whereas only about 1% have a mass of carbon 13, and an extremely small percentage have a mass of carbon 14. You'll need to be given this information too in order to do the calculation of average atomic mass. Knowing all that, you're ready to actually look at the calculation itself. Just keep one thing in mind. If you're saying to yourself, great, I already know how to calculate an average, most people do, just hold on a second, because this is not your typical average. It's called a weighted average. And the weighted average takes into account each isotope's unique percent abundance. So that's really what we're going to go over, is how to calculate a weighted average. For the first example, and this is typical of how most problems will look, it involves copper with 2 common isotopes, 63 and 65. It gives the percent abundance for each. So for copper 63, it's 69.09% abundance, and 65's is a little bit less. The task is to calculate the average atomic mass. First stage in the process is to take all the different masses you're given. In this case, it's only 2, so it's nice and easy, and list them out. I like to do it vertically. You'll see why that works nice later on. Once you've got the masses listed, you multiply them by the percent abundance, but with the decimal place moved 2 digits to the left. So for copper 63, multiply it by 0.6909, not the actual percentage. Same thing for copper 65. Its percent abundance, with the decimal moved 2 to the left, should be 0.3091. After that, you just do the multiplication and write the answers on the end. Once you've got those kind of sub-answers written down, the final stage is the easiest part. You simply add them together. That's why it's nice to write everything vertically, because it's really simple to add them up at the end. And after the addition, you should get a final answer of 63.62. 2 things to notice here. First one, the average is 63.6. Notice how it's closer to the mass of 63. And that's because most of the copper atoms, 70% of them about, had the mass of 63. So your final answer should be closest to the most abundant isotope. It's a good way to check your work. The other perfect way to check your work really is go to a periodic table and check the mass for copper. It should be pretty close to 63.62 that you just calculated. Now that you've seen one example, let's take a look at a second one. Just as always, it's a really good idea to pause the video and see if you can do this on your own before watching me go over the answer. Assuming you've had time to do that, or if you're just going to follow along, here it is. Start by writing down all the different masses. There's 3 of them this time. Multiply by the percent abundance with the decimal moved 2 to the left. Get your sub answers, which should match these. Finally, adding them together for an average mass of 24.46, which should match whatever is on the periodic table for magnesium. And that concludes this video. Thanks for watching.